All right, our final lesson of the year comes in the form of the discriminant of the QF. So that's referring to the discriminant of the quadratic formula that we just learned can solve a quadratic equation, and any quadratic equation, no matter what type of solutions it has. So what we're going to look at today is finding the value of the discriminant. So we'll talk about what it is and how to find it, but then also how we can interpret what that means. I can find the number of solutions and type of solutions for any quadratic equation. Now here on the screen, I've got kind of highlighted what the discriminant of the quadratic formula actually is. It's the thing that we take the square root of. In other words, it's the radicand in the quadratic formula. So whatever value you get for b squared minus 4 times a times c, that value is called the discriminant of the quadratic formula. It's actually the first thing that we calculate when we're solving with the quadratic formula. So it's not that we're learning anything really new with this, it's just that now we know what it's called. So let's take a look at how we can interpret what the discriminant tells us. So the discriminant, again, is that value of the radicand in the quadratic formula. It's just b squared minus 4 times a times c. Now, any number, specifically the discriminant, can be either positive, negative, or 0. Okay, so based on if it's positive, negative, or 0, that actually tells us if there are 2 imaginary solutions, 1 real solution, or 2 real solutions. So we have here a table to help you decipher what that means. So let's start with the more common, the one that we saw in the solutions in the previous lesson, when the discriminant was positive. In other words, d is greater than 0. D stands for discriminant, of course, there. So when that's positive, we will get 2 real solutions, because we ended up with equations that kind of worked out or looked like this, or solutions that look like this. Let's say 4 plus or minus 8 divided by 2. Okay, and we could work those out. We do 4 plus 8, which is 12. 12 divided by 2 is 6. That's one real solution. 4 minus 8, which is negative 4. Negative 4 divided by 2 is negative 2. That, again, is another real solution. So when you have 2 real solutions, you will have 2 x-intercepts. As we learned earlier this unit on a graph, the solutions are on the x-axis, or the x-intercept of our parabola. So if you have 2 x-intercepts, you have 2 real solutions, and that will occur when the discriminant is positive. Now, there is a chance that the discriminant ends up being 0. Okay, in other words, in my quadratic formula, it might look like that. Okay, when we get to a certain point. The discriminant was 0, meaning I take the square root of 0, which is just 0. Now think about it. What's 4 plus 0 divided by 2? All right, well now, what's 4 minus 0 divided by 2? See how we get the same thing? It's still just 2, where if this was the quadratic formula, we'd say that x equals 2 or x equals 2. Technically, that's one real solution, but it occurred twice. It's a double root. When this happens, again, this is when the discriminant equals 0, it's going to give us 1 x-intercept on our parabola, meaning the parabola is going to come to the x-axis, touch it, and then turn back the way it came from. Okay, so when the discriminant is 0, there is 1 real solution. All right, and then our last example, or our last situation, is when we have 2 imaginary solutions. And that's going to happen anytime our discriminant is a negative number. Now, if you think of what that discriminant is, it's the number inside the square root. So maybe I get something like x equals the opposite of b, I'll just say negative 5, plus or minus the square root of something. And that discriminant then, let's just say it's a negative number, like negative 4. Sorry, that's really hard to see. There we go. All over, let's just leave it as 2. When we simplify this square root of negative 4, we can simplify that as 2i. If you remember our unit on radicals, I think it was unit 7, way back, 2i means that we have imaginary solutions. And we end up with two of them because of the plus or minus. Okay, we always end up with those two solutions. But they end up being imaginary, and that's because the discriminant was a negative number. Anytime you try to take the square root of a negative number, you're working with imaginary solutions. All right, so if the discriminant's negative, you have two imaginary solutions. If the discriminant equals 0, you will get one real solution, that's a double root. And if the discriminant's positive, you're going to get two real solutions. So let's look at a few examples. It says here to find the value of the discriminant and then give the number and type of solutions. So in our first example, we can see here that A equals 1, B is -3, and C equals 7. That's just my standard form of a quadratic equation with A, B, C in it. So let's apply our discriminant formula, where we said the discriminant equals B squared minus 4 times A times C. And let's substitute in what we know. B was -3, so -3 squared, minus 4 times A times C. So 4 times 1 times 7. Now you could just use a calculator and type this all in a calculator. Just watch out that that first part, you have to put the -3 in parentheses when you square it. If you don't, it's going to tell you -9, which is incorrect. We know that a negative number times itself is a positive answer. A negative times a negative is a positive number. Now we can multiply 4 times 1 times 7, which is 28. And 9 minus 28 is -19. The discriminant is a negative number. Do you remember how many solutions are there and what type of solutions are they? When the discriminant is a negative value, let's go back to our notes. When the discriminant is negative, in other words, when it's less than 0, there are two imaginary solutions. So number of solutions, I'm going to say 2, and the type, they are imaginary. Let's look at number 2. Okay, find the values of A, B, and C. What does A equal? What does B equal? And what does C equal? All right, now that we have our values, let's use the discriminant formula. So D equals B squared minus 4 times A times C. Let's substitute in our numbers. Let's see, B squared, that was -5 squared, minus 4 times A, and A is 3, times C, which was -4. Okay, so again, grab your calculator, see if you can find the value of -5 squared minus 4 times 3 times -4. You can type that whole thing into your calculator if it works for you. I recommend Desmos.com with a scientific calculator option. So -5 squared is positive 25. So remember, a negative times a negative will always be a positive there. Now when I multiply, I have the subtraction, but I'm going to get a negative number when I multiply those three values. So this is actually going to make it an addition there. Or you could think of it as a negative times a positive times a negative, which is a positive answer. So 4 times 3 times 4 is 48. And 25 plus 48 is 73, I believe. So the discriminant is a positive number. So think about how many solutions there are and what type of solutions. We can go back to our notes. When the discriminant is positive, there will be two real solutions. So two solutions, and for the type, we say that they are real. So now let's actually use the discriminant to help us solve using the quadratic formula a little bit maybe easier, faster. So let's take a look at this example where we see the values of A, B, and C, since our equation is already in standard form. And let's calculate that discriminant. So we're going to do B squared minus 4AC. Let's see, B was 6, so 6 squared minus 4 times 1 times 10. And that's going to be 36 minus 40, which is -4. The discriminant has a value of -4. So again, how many solutions and what type of solutions will we have? Because that's negative, we're going to have 2 imaginary solutions. If we use the quadratic formula to actually solve like we're supposed to, let's see, x equals -b, or the opposite of b, plus or minus the square root of b squared minus 4ac. So this is where we put that -4. We already figured out what that equals. That's the discriminant part. So we can find the discriminant separately first, and then the quadratic formula doesn't appear to be quite as big anymore. Okay, we still have the denominator though. I don't want to forget about that. It's all over 2 times a, 2 times 1. Or I guess we could just say that's 2 at this point. 2 times 1 is just 2. But don't forget to check 2 times the value of a for that. All right, so that's almost our final answer. The only problem is we have a radical that we can simplify. Recall that the square root of -4 can be broken down using the square root of 4 times the square root of -1. That's our product rule of radicals. Now each one of those represents a perfect square. The square root of 4 is 2, and the square root of -1 is what we called I. So really this is just 2i. The square root of -4 is 2i. So now I can simplify my quadratic formula. So x equals -6 plus or minus 2i all over 2. And when you say it's this numerator all divided by 2, that's really the same thing as just taking each part divided by 2. That's actually going to help us simplify here. -6 divided by 2 is -3, plus or minus. The 2i divided by 2 is just 1i. So there's our 2 solutions. Technically, it represents that x equals -3 plus I, and also that x equals -3 minus I. That's really what it means. Those are our 2 imaginary solutions, but we can write it using the plus minus symbol instead. All right, there's our final lesson. There will be a review assignment in the review folder for you to try before taking our final Unit 11 test. Just a reminder, all work needs to be turned in by the end of the quarter, the very last day.